Hi, I'd like to take a quick moment to talk to you about asset data capture. We're from Audital. Audital is a small startup company based in Australia. We've been doing projects, however, around the world in a number of different industries. So when I talk about asset data capture, I'm really talking about the materialized asset data. To give you an idea, my functional data might be that I have a car. It's got 4 wheels, can take 5 passengers. But both of these vehicles fit that specification. And there's obviously a different set of parts, schedules, skills that we need to fulfill that. When I look at a lot of people's asset management systems, this materialized data is what's missing. So it tends to look like this when we get into the asset management system like SAP or Maximo or Oracle, where you'll have the functional information coming from engineering, and that'll be relatively well known, but what actually is installed there at that location? It's generally either blank or wrong when it comes down to looking at what's actually physically installed. And all of that leads to a loss of trust in the asset management system. And I guess that's the key thing to ask. Do your people trust the data in your asset management system? And all too often the answer is no. So really what we're about is finding the assets. Now, surely it can't be that hard, right? Just give somebody a tablet and send them out into the field. Well, actually, a tablet and keying it in is a lot slower than writing it down. So that's one thing for the guy in the field. But what you see is the guy in the field, it's not his main job. He doesn't want to do that. Nobody gets up in the morning and says, I want to go out and capture data. And because of that, and because of the nature of the job, we see huge error rates. So in this example on the right here, we see a transmitter model number, and every one of those characters is important. The chances of getting that written down accurately in the field are pretty low. And it's actually really expensive. If we looked at some average man-hour rates and rates of capture, it can be really expensive just to get somebody in front of an asset. So that's why most of that data stays in that situation, and that compromises maintenance performance and supply chain performance. Because really, until you actually go and look at what's involved, it's quite difficult. So if I looked at that nameplate there and asked you to write down the model and the serial number, I would have a range of data coming back to me. And then we consider that a lot of the locations where people need to go to capture this data and the type of equipment people need to wear makes it even harder again to go capture data out in the field. So what we do, quite simply, is we say, I don't want anybody entering any data. I just want to take a photo. And what we find is that if you're only asking somebody to take a photo, then you're changing what you're asking. It becomes, instead of several minutes sitting down writing something down, you've just taken a photo and moved on. The traditional process, as I said, is writing something down. It's very error prone. Then you would have to transcribe that. Even it would go slower if you did it in the field. Then photos are part of it, but you have to then manually rename those photos potentially and upload them into your document management system. And all of that takes time. So the rule of thumb doing the traditional process is that you are using about 12 minutes per asset. In an 8-hour day, that means 40 assets a day at $75 an hour. It's $15 an hour, $150 an hour. You could be looking at $30 an asset to go and capture that data. And as I showed before, you can't just send anybody out there. They need to understand what data off the nameplate needs to be extracted. Also, that traditional process leaves you open for lots and lots of errors along the way. So what we're trying to do is say, well, if I can take 200, 300, 400 assets a day, I dramatically drop the cost to capture that data. And if I've got good quality data, I'm going to get better asset management outcomes as part of that. So Audital customers are generally getting around 200 a day. There's a lot of variables go into that. It might be down at 60 to 70. Some days it might be, I think the highest we've had is around 600. So a lot of variables, but on average, that's kind of what you would expect in that range. And, test it yourself on all the different nameplates that you might have out there. To go and that's a really good quality nameplate, by the way, but you send somebody out there to capture that, and they'll spend quite a lot of time doing that, and it's highly error prone. But given that we're just taking photos, what it does is opens you up to being able to use a lot of lower cost resources. In your traditional audit, where you send somebody out to write down or capture all of the attributes out in the field, it takes time, and you need an experienced engineer who understands exactly what attributes out of that nameplate you need to get. But if all I need them to do is to take a photo, it changes the dynamic. And we successfully did a project in North America where 82% of the photos taken on nearly 8,000 assets in a refinery were just done by college students on a holiday break. Dramatically dropped the price of capture, and the results were awesome. So what we're about is trust and building trust in that. So another thing that we're capturing here is metadata. If I look at an asset management system, it might just have make, model, serial number, but when was it seen like that? So what we're capturing here is where was it, who captured it, what time was it captured, to build up trust. But also, a lot of assets are actually assemblies. So what we do is allow you to capture those assemblies. So in this case here, in the asset management system, it might be a control valve. But when I get there, there's a lot of other things like an actuator, a positioner, and other bits and pieces that might be at that location of the control valve. So with one click, we can capture all that. So the app captures and organizes all of this information. And we're literally following the same process of turning these photos into information that people have used for libraries for years. If I just had a building full of books, I can't get information. But what we've added is classifications and cataloging that lets me understand what is in the book and where I can find it. And we do the same thing. So we have a mobile app. We don't want just any photos. We want reliable photos that have been classified as to what's in them and where they are. And we build a big data archive of all of those photos. So we know what's going to be in each photo and what it's about without even looking at it. But then we send it off to crowdsourcing to extract data from it. A lot of the automated methods you hear about kind of don't work that well when it comes to nameplates because they're highly variable, but they're also very damaged a lot of the time. Crowdsourcing we've found works really well. So what we do with that is we ask lots and lots of people in the crowd, and we pay them for their work, to give us some data back from the photos. This allows us to do it at scale. It's very, very fast, so we can plug into literally millions of workers around the world, and they execute those jobs. So we build those jobs to get smarter and smarter over time to ask questions that people answer. And it doesn't just have to be questions of please enter this text. It might be condition-based information. And this was a job I did for a water company where we wanted to know the condition of each of these water meters so that we could calculate a cost to replace it with a digital meter. You can see here is it's got a green pipe at either end, green tinge, that indicates it's copper. If it was galvanized pipe, it would be a different cost profile. If it's in a pit or it's concreted rather than earth below the meter, that's another cost profile. So we can do all sorts of things with this methodology. But the first thing we do when we start to set up a project is we say, well, what do you know about the data at the moment? Because we want to verify what you've got. And then we build a strategy on the cloud. We sync it with the mobile app, and people go and capture data. We process that data and send it back to your enterprise asset management system, your EAM system, so that it can be loaded. But what we also do is look at the data itself. The companies on that asset that made that asset change over time. If the facility is 10 years old, our rule of thumb is that half of the companies related to that asset don't exist in that form anymore. So what we do is we connect the asset that you operate to a manufacturer that produced it. So an example of that might be this photo I showed before. PBV USA Inc. doesn't exist anymore. It was bought and sold several times, and now it exists as a brand of Forum Energy Technologies. So from a maintenance and supply chain point of view, I need to know that if I have an issue with this particular ball valve, I need to go and speak to Forum Energy Technologies. Where do I go to do that? And I need to make sure that's set up in my supply chain system so that if I need to be purchasing anything, I have the representative of Forum available to me. And it's not just the manufacturers. We do that with any company that's related to it. If I look at an asset and the information on that asset out in the field, I might have a label from somebody that's doing a calibration, or somebody who sold it, or somebody who's servicing it, in addition, of course, to the manufacturer. So the way it exists in this case here, we'll see I've got Southern Cross as a pump, and Rob Lane was the vendor. So the data we can see there up top is what we've extracted from the photographs. From our database, we connect to our database, which shows that Pentair actually has Southern Cross as a product division now, and Brown Brothers Engineers purchased Rob Lane some time ago. So that sits in our database. So we have a database of these companies and brands that are kept up to date by synchronizing with the Dun & Bradstreet database on a continuous basis. So we understand and we can keep track of these changes essentially in real time, so we can understand the impact on the supply chain system as we go through. So we know where that's traceable. Likewise, if we can't trace something to a current operating entity today, that also highlights a risk, and you'd need to consider whether it's safe to keep operating that equipment. So the way we send that out, we can then do a report. So in this case here, reporting on a particular change where I can see that UTC's disposed of this particular valve company and an Italian valve company's purchased it. Another example with some Canadian valves, and this is a good, some Canadian devices from Dover, that you can see a good example of some of the damaged nameplates that we typically deal in. Once again, these typically aren't the worst we would see, but what you can see, we've extracted the make and model, but we can also see that it belongs to Alberta Oil Tool Company, which is part of Dover. And we can follow that through, and we can see that it was all in sync as we did it. The data that we prepare, the ultimate goal of that is to get it back into your enterprise asset management system, your SAP, your Maximo, etc. We can keep the data in there and keep updating the manufacturers. We can keep updating it as you go forward and collect more and more photos, but ultimately we're sending that data back to your organization. We can use standard interface technology, but quite honestly, most of the data that we send out will always go back through Excel, and that's simply because most companies have well documented interfaces between the using Excel with standard upload and export templates, and we just fit into that. So we've done a lot of projects in facilities, utilities, oil and gas, all over the world. We've worked with some really great companies all over the world with a lot of successful projects in a lot of different industries. But one thing I'd just like to leave you with, it's changing the dynamic of what data capture is. No longer am I saying I'm going out and capturing attributes. What I'm doing is capturing and classifying large amounts of photos. So I'm building up a data bank that I can use as a resource for the future. So let's say my current need was that I just wanted make, model, serial number. But in future, I had a project where I needed to know the refrigerant code and the weight of the refrigerant. I don't have to extract that today and pay for that today. I can extract that in the future and get attributes just in time. And I can turn that around very, very quickly. The current process, capturing attributes, you have to decide in advance every attribute that you need for every future project before you go out and collect data. We just start taking photos and we can generate the attributes to support future projects as required. So we're faster, typically 3 to 5 times faster. We use lower cost resources. So the combination of being faster and lower cost resources means that projects to capture data are generally dramatically cheaper. You've got a rigorous process, so it's a lot more accurate. And the way we go about it means we're in and out of hazardous areas a lot faster, so it's safer. I've enjoyed the opportunity to share this with you. Please do click through and make contact with me if you'd like to know any more. The best way to go through this and show what we do is a small pilot project. I'd love to talk to you how we might be able to pilot this in your organisation. Thank you very much for your time.